Good morning or afternoon, fellow students. You're welcome again to our e-learning. And in the previous lessons, we're dealing with group theory. So today we are going to a new chapter. Please always make sure you follow up the lessons and ask questions. Assignments should be done. Exercises, you do them well in order to save time. We are moving ahead. We are not coming back. Please always make sure you do what is right. So today we'll be working with Cartesian coordinate geometry. So now, when you hear of the word geometry, what's the first thing that comes to your mind? Yes, okay. Somebody is talking of straight lines, yes. Angles, all right. So when we talk of geometry, we are referring to lines, angles, and their properties. So if we have this situation, then we're talking about coordinate geometry. So look at what we have. Cartesian coordinate geometry. So Cartesian here means we are going to look at the Cartesian plane, which has the x and the y axis. So before we go to that, let us look at the first lesson and the application of coordinate geometry in our lives. You know, you cannot do construction and so on when you don't know how to come up with straight lines, and so you have to draw the plan of a house. You need to look at the lines. You need to know how to put the lines in a rectangular, triangular shape, and so I should do some measurements. So coordinate geometry will always guide us to do that. So our first lesson will be the distance between 2 points. The distance between 2 points. So now, with the distance between 2 points, we are going to start with an activity. We start with the activity, we follow the activity well, and we work exactly as instructed. So, we take the first activity. It says, draw the coordinate axis on the Cartesian plane. Next point, plot the points A with coordinate 2, 3, and B with coordinate 5, 6. Next point, connect A to B to have the points AB. Next point, state the distance from A to B. Alright, now we are about to do the activity. They say we should draw the coordinate axis on the Cartesian plane. The coordinate axis here refers to what? The x and the y axis. Y is always vertical and x is horizontal. And mark you, when you are drawing the vertical and the horizontal axis, it leaves from negative to positive. So when I'm drawing, I will have in mind that I have both the positive and the negative directions. So 0 is always at the center. So if you look at what I've done here, all of us are working together. You have the vertical, you have the horizontal, and then you look at my center point here, 0. So you have the y and the x axis. So I've indicated the axis. Now, after doing that, I have to also come out with points. I'll make a scale. When I make a scale, I'll put the points. And the spaces between the points must be the same. So if you look at it, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? This way I have negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, and so on. The distances between them must be the same for you to plot any point. You make sure you come up with a good scale. At times, it might be the same for the x-axis and different from the y-axis. All is that on a particular axis, the scale must be the same. You should be very careful with that. If you look at what I have here, my scale on the x-axis, the distance between each pair of points is the same. 0 and 1, the distance is 1. Then 1 to 2, the space between them is 1 unit. 2 to 3, the space between them is 1 unit. Right? So now it's time for me to plot my points. So for the point A has coordinate 2, 3. So I'll come to the x-axis, I look where I have 2, I place my ruler on 2, and then I look for where I have 3 on the y-axis. I will now stretch the line to meet the 2 that is coming from the x-axis. Then I mark my point. So I have 2 for x, 3 for y. I will do same for the next point, 5, 6. So I have 5, I take it up to the point where I have 6 on the y-axis. I plot the point. Okay, I have plotted the points A and B. You did this in form 3. Now I need to connect the points A to B to have the point AB. I'm connecting the point A to B using a straight line. So I put my ruler and I connect. When I connect, I measure and keep the result. Okay, then when we use the general formula, you can now test and see if the result you measured is the same as when you have the general formula. That is what happens, and you always give the same result. So at this point, I have plotted, I've connected, and now if you look at what I have here, there's something coming in new now, very small. I have plotted, I'm done with the activity. I want to come up with something new. If you look at the points A and B, I've introduced another point C. How did I introduce C? I just made dotted lines from B coming down straight, and dotted lines from A going horizontally. Where they meet, they form a right angle. Okay, that's why you see the symbol for the right angle there. I can now use C to denote that point where they meet. Okay, now from the Pythagoras theorem you learned in Form 3, we always say the sum of the squares of the side should always give the square on the hypotenuse. Okay, so the hypotenuse here is the distance between A and B. I'm gradually taking you now to the general formula. So like I said, the hypotenuse is the distance between A and B. And from the Pythagoras theorem states that the sum of the squares of the side should always give the square on the hypotenuse. Look at what happens. The sides from A to C, if C has a point here and another point here and another point here for A, you see we're dealing with the x-axis. So you can have here x2 and this way x1. When I'm moving vertically, I read here and read here on the horizontal axis. Now if I'm going horizontally, I will now read here and read here on the vertical axis to have my y1 and y2, y1, right? So this way, the first point here is x1 and coming down here is x2. Then this way, the first point here is y1 and up coming this way is y2. So the difference between B and C is always y2 minus y1. The difference between the point A and C is x2 minus x1. So now apply the Pythagoras theorem. The distance here is AB squared, which is equal to the sum of the squares now, x2 minus x1 all that square plus y2 minus y1 all that square. At this stage, you are not required to prove it. I'm just explaining. Now, when I have it required, I need a distance, not distance square. So I'll just take the square root of x2 minus x1 all that square plus y2 minus y1 all that square. Recall Pythagoras. We are still going to see it in trigonometry. All right. So like I said, we are moving to a general formula. So at this point, we say if A has coordinates, x1, y1, and B has coordinate x2, y2, and the distance between, recall we're looking at the distance between A and B. So the distance between A and B now will be given by d of AB. You can just use capital letter D, it's okay. D of AB will be the square root of x2 minus x1 all that squared plus y2 minus y1 all that squared. This is the general formula. Now that I have the general formula, we need to be very careful. Distance is never negative. It's always positive. And the distance is the same as the length. You cannot say the length from, or the distance from Mike Denny to Post Central is negative 50 meters. It is not possible. Distance is always positive. We say the length of your ruler is 30 centimeters. You say the length of that ruler is negative 30 centimeters. No. So distance is the same as the length and it is never negative. So we have that remark, and now we are moving to enjoyment. So for our enjoyment, I'm going to read them. I'll read the enjoyment and we'll progress from there. The first enjoyment says you should find the distance between the following pairs of points. The first one is talking about the point A, 1, 3 and B, 3, 5. The second pair of points we have C, negative 1, 2 and D, 2, negative 3. Alright, then the second question, what is the distance between alpha, beta and 2, 3? So here, since the values of alpha and beta are unknown, you solve and leave your answer in terms of alpha and beta. Then you go to the third question. It says the distance between the point P, 2, 5 and Q, A, 3 is 5. Find the value of A. So you are going to use the general formula and calculate the value of A. But I'm going to solve the first one for you to see and follow what is happening. Then you do the other part of the question. Alright. Now, looking at our enjoyment says we should find the distance between the point A, 1, 3 and B, 3, 5. So I have my point here, A with coordinates 1, 3, B as coordinate 3, 5. Recall, A is the first point, and the first point is always having coordinate named x1, y1. And then the second point always have coordinate x2, y2. So here x1 is 1, y1 is 3. Here x2 is 3, y2 is 5. But my formula says D is equal to the square root of x2 minus x1 all that square plus y2 minus y1 all that square. Alright, so I'm just going to substitute the values of x1 x2 in the given formula. So here x2 is 3 minus x1 which is 1 all that squared plus, now we have y2 5 minus y1 which is 3 all that squared. So 3 minus 1 is 2, all that squared is 4. Then we have 5 minus 3 is 2, all that square is 4. 4 plus 4 gives 8. So we are left with the square root of 8, but not if our answer like that, we must simplify it and put it inside form. So putting inside form, 8 is the same as 2 times 4, and the result is 2 root 2. But remember, we're talking about distance, so you put it in units. If the units are not given, you just write 2 root 2 units. That is the distance. So we are done with the first part of question 1. So you are going to do the other ones for me to evaluate you and know exactly what is happening. For those of you who have not been coming online, please endeavor to come, solve, present your problems for me to explain and also assist you to understand the concepts. If you miss this lesson without coming online to know what is happening, you might end up not following up the other parts of the lesson. Please always endeavor to come online and know what is happening. It's been a pleasure working with you guys, and have a nice day.